of the signal cosine 4 pi t times u of t is a periodic signal or not. So one way to think about this is to set this signal to be x of t, or x of t to be cosine 4 pi t times u of t, and then you are asked to determine if the even part of x of t, which will be 1/2 times x of t plus x of negative t, is a periodic signal or not. So when you're asked to solve these kinds of problems, I suggest that you sketch some of the signals involved, like x of t and x of negative t, and to get an intuitive feel about how to solve the problem. And then you can work out the math too, and hopefully there you see that your intuition matches with what you get from the math. So let's start by sketching the signal x of t. Notice that x of t is the product of two signals. It's cosine 4 pi t times u of t. So if I think about sketching x of t, I would get a signal which looks like this. That's because we start with the cosinusoid. Cosine 4 pi t is a signal that goes on forever and from time t equal to negative infinity to positive infinity. And you have a unit step signal u of t, which is 0 if t is less than 0. It's 1 if t is greater than 0, and at 0 it takes the value 1/2. So when I multiply these two signals together, I'm going to get some signal like this. At 0 this is going to be 1/2, but I'm not showing that, but you're just going to get the positive part of the cosine. You're going to get the cosine 4 pi t for positive values of t, and then at 0 it's going to be 1/2. So let's try to sketch x of negative t. We have x of t, we have x of negative t, and then we can find the even part of x of t from these two signals. How does x of negative t look? Well, you can get x of negative t from x of t by taking x of t and flipping it about the y-axis. Right? That's what x of negative t is. So then you would get a signal like this, which would be the flipped version of x of t. To get the even part, you can add these two signals together and divide it by 2. Just to remind you, the even part of a signal is 1/2 times x of t plus x of negative t. So when I add this signal and this signal divided by 2, I'm going to get some signal like this. And this is 1, this is 1, this is 1/2. Okay? Now, notice that this signal is actually exactly the same as 1/2 times cosine 4 pi t. Right? And that's because cosine 4 pi t itself is an even signal. So when I take this part, when I flip it about the y-axis, I'm going to get something which is actually exactly the same as what you had in cosine 4 pi t. You can see that here. So in the end, the even part of x of t turns out to be simply 1/2 times cosine 4 pi t, and indeed this is a periodic signal. This is periodic, and the fundamental time period is 1/2 second. Okay. Now I also want to take some time to explain how to solve this problem without explicitly drawing these pictures and just relying on the math. Again, we're asked to compute the even part of cosine 4 pi t times u of t, and let's start by thinking of cosine 4 pi t times u of t as x of t. What is x of negative t? Well, x of negative t is what you get by replacing t with negative t in this expression, right? So x of negative t is cosine 4 pi times negative t u of negative t, which is cosine negative 4 pi t times u of negative t. But notice that cosine of negative theta is the same as cosine theta, right? So cosine negative 4 pi t is the same as cosine 4 pi t. So x of negative t now becomes cosine 4 pi t times u of negative t. How do you get the even part? Well, to get the even part, you take x of t, you add it to x of negative t, and then you divide by 2, right? So it's 1/2 times cosine 4 pi t plus cosine 4 pi t times u of negative t. When you add these two together, I could factor out a cosine 4 pi t, then I end up with 1/2 times cosine 4 pi t times u of t plus u of negative t. And let's think about what u of t plus u of negative t is. So u of t is the unit step function, right? It's defined to be 1 if t is greater than 0, 1/2 if t is 0, and 0 if t is less than 0. So if I add u of t, which looks like this, to u of negative t, notice that I get 1 for all values of t. So indeed, this is 1 for all values of t, and so I end up getting the even part of x of t to be 1/2 times cosine 4 pi t. Right? This is exactly what we got when we sketched these signals as well. And of course, it's now clear that it's a periodic signal with a time period of 1/2 second.